All right, happy Tuesday. I want you guys to know that you guys are doing great. I'm very happy. I'm impressed how much you're doing. We're going to keep on trucking, lesson 64. I do want to say one thing. The homework quiz I've got scheduled for Friday. Um, I'm still kind of debating on how exactly I'm going to do it. It will be homework questions, but I probably will not use the exact numbers that are in homework problems. That they will be exact similar problems that you will have. I just don't want you to be able to look at your homework and see and just write down an answer. Not saying that anybody would look at their homework during a homework quiz. I would hope you wouldn't. But I probably will just change up a few numbers, name, letters, stuff like that. But they'll be the same type problems. And that will be from the lesson 61 since we started through 65. So we'll have some more problems tonight and tomorrow. And then I'll answer any questions you may have. And then we'll take a homework quiz on Friday. So let's keep going with lesson 64. Angles interior to circles. There is one definition that we need to write because you do have two theorems in this lesson, and you kind of need to know what this definition means to make sense of those two, well, just really the first one. All right, starting at the very beginning on page 424. It says a segment or arc. And I'm just going to write down what it says. A segment or arc is said to subtend. That's our definition. What in the world does subtend mean? It subtends an angle if the endpoints of the segment of the segment or arc lie on, that's supposed to be an or arc, lie on the sides of the angle. Okay, so what does that mean? Okay, so we're going to have circles. If you couldn't tell by the definition, we're going to have some circles in this lesson. Okay, and then we're going to have, it can be inside the pieces. All right, so they do an E. Okay, so it would be said that arc EF, okay, subtends angle EDF, okay, or line EF subtends angle EDF. Or they, in your book, they say angle EDF is subtended by EF or DF. So really what we're looking at is this arc or this segment subtends this angle. Okay? So, in theorem 64-1, let's look. Now, they do it this way, but I would like to say we can do it a different way. Sometimes our sides, our lines, let's go back to this. I'm just going to do lines, will be on the outside. Okay? Okay, but do you still see an angle? Does everybody see an angle here, A, B, C? So that angle, A, B, C, can be subtended by the arc, AB. Okay? Or if I put another letter over here. I didn't use the same letters that they did in the book. I'm sorry. You can put another one over here. I'll name it D. We could have angle ABD is subtended by probably if it's a major arc, I need 3 letters. By arc A, E, B. Okay, remember your arcs. 2 letters is a minor arc, like over here like this, AB. 2 letters is a minor arc. 3 letters is a major arc, meaning more than 180 degrees. Okay, so if you're looking, it says, look, Theorem 64-1. The measure of an angle formed by a tangent and a chord. Okay, here's our tangent. Here's our chord. Got to remember our definitions. Is equal to half the measure of the arc it subtends. Okay, so the measure of the angle is equal to half the measure of the arc. This is very similar to an inscribed angle that we did not that long ago. Actually, I'm going to look at this one. The inscribed angle, remember EDF, is an inscribed angle. And it said the inscribed angle, we'll just put an X, is equal to half the measure of the arc. So if EF, arc EF, equaled, well, I'm just going to put a 2x in this case. It would be twice as much. So if EF equaled, I'm just going to say, for example, 80 degrees, what would the measure of angle EDF equal? That's right, it would be half. It would be 40 degrees. Okay? So now we're just taking this angle a little bit outside. Meaning over here, my angle is coming even outside the triangle. Okay? So angle ABC is equal to half the measure. Okay, I'm just going to write it. Angle ABC is equal to half the measure of arc AB. That's kind of what your book says. They put the little M for measure. I just say it. Okay, so I'm going to scroll down just a little bit and give you a number. What if the measure of angle ABC is equal to, that's about, say, a 70 degree angle. How about that? So angle ABC is 70 degrees. So I could put it in right here, 70 degrees. If I have a formula, there's a formula there. And I know the measure of angle ABC is 70 degrees. Can I find the measure of arc AB? Well, it equals half the measure of arc AB. Well, how do I solve for the measure of arc AB? I multiply both sides by 2. So arc AB out here would be 140 degrees. Okay? From all of that, could I find the measure of angle ABD? Could I do that? What is the measure of angle ABD? Even if I don't give you anything else, can you find it? Of course you can, because you know that DBC is a straight line. That's right. So this angle, I would subtract 180 minus 70, and I would get it's 110 degrees. Okay? Well, from there, could I find the arc AEB? What's the measure of arc AEB? That's right. It would be 220 degrees. It is simply double. Could I have just subtracted 360 minus arc AB? Why did I choose 360? Because it's a circle. It's 220 degrees. I got the same thing. Okay? All right. There's a good question that gives you both pieces. I think I gave you one. Maybe we'll do one more. If I give you a circle and a tangent line, a line that's going straight across, and a chord, we're going to make it actually touch the circle here, And if I give you this interior angle, this angle right here, it would be helpful if I'm on the pen again. If I give you this angle right here is, let's say, 40 degrees. What's the measure of arc X, Y? That's right, it is 80 degrees. We're simply doubling. If you have the angle, the arc is twice that much. Go from a line, which is 180, to a circle that's 360. That's how you can remember that. Okay? What if I gave you, what if we had a circle and I gave you that, and I tell you that this arc from A, W, Q, I tell you this arc is, I want to be nice, we'll just say 202 degrees. I probably need another letter too. And I ask, what is the measure of angle QAC? What are you going to do to go backwards and find the measure of this angle? That's right, it's going to be half of the arc. So it would be 101 degrees. Good job. All right, there's another theorem that we need to look at. It's theorem 64-2. It says the measure of an angle formed by two chords intersecting in a circle is equal to half the sum of the intersected arcs. So what does that mean? Well, in this case, it means we're not having a tangent line to go around it. Okay, it says two chords. Now, what are chords again? They're line segments that go through a circle that has endpoints on the circle. Okay, I'm just going to draw one of these. We're going to put some letters. I'll put C as my center, and other points all the way around that are Q, R, S, and T. Okay? And I want to find the measure of angle 1. Okay? Angle 1 is actually QCT. Okay? And this theorem says I can find the measure of angle 1 if I know the measures of their arcs that intersects. Now, what are you talking about, Miss Evans? I only see one arc that it intersects, right? But what do you know about any two lines that cross? This angle must equal this angle. You're right, vertical angles. And what do you know about all vertical angles? All vertical angles are congruent. So really, this side is the exact same as this side. So where I put that C, there could also be a little number 1, because those two angles must be congruent. Okay? So now I have two arcs that they intersect. Okay? And it says it's the average, or you add them together and divide by 2. It's the average. Okay? So if I know arc Q to T is, we're going to say 75 degrees. And we're going to say arc R to S is 95 degrees. Can we find the measure of angle 1? Okay? In your book, in the theorem, it says the measure of angle 1 is equal to 1/2. I don't know what letters they use. They don't use mine, so I'm going to use my letters. The measure of QT plus RS. Okay? We're simply going to average. We're going to add them together, so 75 plus 95. And then I'm going to take half of that. So I'm pretty sure this is 170. Not the prettiest number I've ever made up. So what is half of 170? 85? Is that right? I think. So the measure of angle 1 would simply be 85 degrees, of course. If I wanted to say, well, what about the measure of angle 2? Could I find the measure of angle 2? Yes, well, let's do it easy way. This makes a line. If I know this is 85 degrees, what does angle 2 have to be? I'm subtracting 180 minus that, and it would be 95. Okay? I'm going to do a different example of what would happen if I gave you the angle, the measure of angle 1, and we didn't know one of the arcs. Okay? They do that. They do one similar to this one that I did in your book. So you've got another one to look at there. But let's look at what happens if completely making this up. We're pretending. So this we're going to say, oh, I need to make it somewhat believable. It's okay. We're going to say this is 61 degrees. So I'll give you the measure. And this piece here is 95 degrees. I'm asking you to solve for y. I'm asking you to solve for the measure of angle y, or the arc y. Okay? So the angle, the measure of the angle, equals 1/2 of the two arcs added together. Okay? I should have used the other letters. Let me not use them one. So my 61 degrees will equal half of 95 degrees plus y degrees, the two arcs. Okay, so how am I going to solve this? Algebra helps tremendously, but there's a great thing, couple different ways you could solve it. Okay, could I distribute the 1/2 to each piece? You could. I personally would suggest you take each side and multiply it times 2. Why in the world would I say that? Because it's going to get rid of this half. Because 1/2 times 2 is just 1. So now we have 95 plus y equals 2 times 61, which I believe is 122. And it's still degrees. And then solving for y is really easy. We can just subtract 95 degrees from both sides. When you subtract 95 from 122, I believe you get 27 degrees. Is that correct? I think it is 27 degrees. So y would be 27 degrees. So you don't have to be given both arcs, but you have to be given 2 out of 3 of the pieces that you are going to have to use. Okay? They do an example of somebody laying tile in the kitchen in a circular pattern. I've laid tile before. I would never put it in a circular pattern or whatever, but they give you 2 arcs and ask you to find the measure of the angle. You simply add the 2 arcs, divide by 2. You're averaging them to find that angle. All right? Keep rocking this on. We're going to have lesson 64 homework. We're going to do the practice, but we are not going to do letter C. We're only going to do practice A, B, D, and E. Okay? And numbers 8 through 11. Any questions? Talk to you later.